this is question 28 from the GATE 2016 session 3 EC paper, where we are given two surfaces, that is a subset of the XY plane and another plane, right? And we are asked to find out what the volume of the common, that is the common region between them is. Underneath the question, you will find the title of the NPTEL course or video relevant to this topic. So a little bit of background. So what the question has given us is actually two surfaces, right? And if you want to find out what the volume is that is caught between these two surfaces, that is, what is the volume of the region that's encapsulated by these two, then this is the way to do it, right? Let's say you have this region which is described in set builder notation over here, where you have two surfaces and you want to find all the points x, y, and z such that x and y belong to this shadow and z is bounded by these two surfaces. So you want to find the volume of a region that is described like this, right? X and y will range over this shadow and z will be caught, or rather z will be bounded between the two surfaces. So to actually find the volume of this, you have to do a triple integral dv, right? Which can be given as double integral over the shadow. This is for x and y. That's why I've given it as dA. And the innermost integral will be the dz integral between the two surfaces. A little bit more of background. You also need to know how to perform the area integral. If I give two curves and ask you to find the area of the region that is sandwiched between these two curves, right? So now I'm given the curve as y equal to f of x notation, and so the area, it's very similar to the previous thing, except now it's just a double integral. The inner integral, because I've given it as y equal to f of x, it will be in terms of dy with the curve equations f of x, the two functions as the limits, and a and b are the outer integral limits. So this tells us how to perform the outer surface integration, and this is just a simple Riemann integral, right? Again, this region I have described as a set builder notation here for for there to be no ambiguity. So with all that preface, let's start the problem. So the problem describes a region of finite area on the xy plane, which is this. I've taken the liberty of drawing the xy plane diagram separately so that it can be more easily visualized for the second half of the problem. And this is the a segment of the plane x plus y plus z equal to 6. So it's asking us to find out what is the volume of this region that is caught between these two surfaces, right? And the region, again, I've given it in set builder notation, and I've defined the two curves, the two surfaces S1 and S2, right? This is z equal to S1 is one surface, z equal to S2 is another surface, right? I've just expanded the S1 and S2 over here, right? So because it's the xy plane, you will have that it's just z equal to 0 is one of that. So the volume of the region, and what is going to be the shadow, right? So we also need to know what the shadow is, right? Because that's where the outer integral has to be performed over, right? So over here, the shadow is simply the region, the finite area region on the xy plane, right? I have used D over here. I'll just replace it by S to be consistent with the previous background. So the shadow is just going to be R. I have labeled it as R in the figure. So maybe I'll just call it R over here. Right? So let's actually, so once you perform so the inner integral is easy to perform, right? it's the outer integral that will be a little tricky. And the region R is again described over here in set builder notation, same like over here, right? You can pause the video to check it. It's basically x over limits 0, x equal to 0 to x equal to 3, and y being caught between two curves. One curve is just the line y equal to 0, and the which is the x-axis, and the other curve is just the line y equal to 2 by 3x. So with all the setup all the necessary setup finished, we can actually go ahead, put in the values and compute this volume, right? So this is the dA portion and this is the inner dz portion, right? And you can so after you have set up this triple integral, it's fairly straightforward to go over the each integral and find the answer. It will come out to be that the answer is 10. That is the volume of the region that is asked is 10.